Let's try to solve this question over here. A simple way to make a resistor of high resistance is to draw a line with a graphite pencil across a sheet of insulating material. Okay, so we are referring to a normal pencil, a 2B pencil or a HB pencil that you have been usually using. So if you use that kind of pencil and you draw a line on the paper, let's say. So what happened is those pencil, right? Let's take out a pencil to demonstrate the idea. Okay, so if you happen to have a pencil, right, this pencil here, inside here is made of carbon. So to be more specific, this carbon is called graphite. Okay, so when you slide the surface of the, if you slide the tip of the pencil along on the paper, what happens is layers of graphite actually get shaved off the tip of the pencil and it sticks onto the surface of your paper. So you can think of it as if you are leaving some traces of some layers of graphites onto your piece of paper when you're writing or you're drawing a line onto your pencil, onto your paper, sorry. Okay, so you can imagine, because it's a layer or a few layers of graphite left on your paper, so definitely there will be some thickness to your graphite. So it's not exactly 2D, there's a bit of thickness to your graphite layer. Okay, and of course there's width and there's length as well. So you can think of it actually similar to be a cuboid. Okay, so you can think of this graphite here to be something like a cuboid. Okay, instead of thinking of it like one single straight line, you should probably think of it to be something like a cuboid. Okay, so a cuboid will definitely have length, have width, and also thickness. Okay, so this is how we are going to think about this graphite layer over here. Okay, let me tidy up my diagram for a little bit. Okay, never mind. Okay, one such line has a resistance of 10 mega ohms. So this line over here in particular has a resistance of 10 ohm and it's 80 cm long. Okay, 80 cm and 10 mega ohm, all these things comes with prefix, so you have to change it into SI unit. 10 mega ohm, mega is times 10 to the power of 6. Why am I writing it as 10 ohm? My mistake. So you have to change the mega to be times 10 to the power of 6, because that's the meaning of mega. So times 10 to the power of 6 ohm. Then 80 cm, you have to convert it into meter, which is the SI unit for length. So that will be 0.80 meter. I hope it's clear. Okay, so we can call this as a length. We can safely call this as length. Okay, then next, if its width is 1.8 times 10 to the power negative 2 cm, so width will be us measuring from here to here. So this is 1.8 times 10 to the power negative 2 cm. Oh, this is really sly. They use exponent, but they still put it in cm, so we have to convert it as well, I think. Okay, let me double check. Yeah, you have to convert it. So let's change the question. Okay, let's change it to meter. It's quite not reasonable why they put cm but they still put the exponent. Okay, so 1.8 times 10 to the power negative 2 meter. Okay, let's just keep it simple that way. Okay, then they ask what is average thickness. So thickness represents the height in this cuboid. So let's label it by T, thickness. Okay, so we know that our current, okay, if we apply a current, or if we apply a potential difference to this line, current will be flowing in a direction like this. Okay, so if we know that, then we can see that this here will be our cross-sectional area. Okay, if our current is flowing this way, then this surface over here will be our cross-sectional area. Okay, so let's label it as cross-sectional area A. Okay, and if you want to keep it more specific, this area here is actually a rectangle, which can be obtained by doing width multiplied by thickness. Then you're able to get the cross-sectional area. Okay, so now if you are clear with how everything relates to each other, I believe you can find average thickness. Again, it's just length, resistance, area and you have your resistivity, well, it's still the same formula. The formula that discusses the factors affecting resistance. So the factors affecting resistance are resistivity, the length, and the cross-sectional area. They are very still the same thing again and again, so nothing much to be explained actually. Okay, so we know that resistance is equals to rho L over A. Okay, I usually write it that way. Some people write rho as a subject, but I prefer to call R as our subject, resistance as our subject, because our resistance here is dependent on three different factors, which is the resistivity or the type of material, the length of the conductor, and also the cross-sectional area of the conductor. So I prefer to arrange it that way. Okay, of course, it's just algebra. Okay, so nothing to be worried about. So you have the resistivity. The resistivity is 6.3 times 10 to the power of -5. We are going to keep the keep it as it is. Okay, the length here will be 0.80. We convert it into SI unit, 0.80. But for the area here, we are going to expand it and change it to be the width multiplied by the thickness. Okay, so we can further do our substitution because we have the width, or we don't have right now. It's just the thickness or the height. Okay, so the width here will be 1.8 times 10 to the power -2. That's the width. Then the thickness, I'll just leave it as T. Okay, we know that the resistance here has a resistance of 10 mega ohm, so we put 10 mega ohm over here. Okay, so everything is set. What we don't have right now is only the thickness. So if you put it into your calculator, I believe you get the thickness to be equal to 2.8 times 10 to the power of -10 meter. Okay, so nothing too complicated. This is about how many times is this? 0.28 nanometer, right? This one is 0.28 nanometer, which is really thin. Okay, that's why we don't really see that there's much thickness to the pencil traces that we have on our paper, because it's actually really thin. Okay, but you can think that there's a finite thickness. That's why there's a graphite layer, so it can conduct electricity. Okay, carbon is actually not a really good conductor, but if you shape it into a different structure, let's say like graphene or graphite, if you shape it into that kind of very thin structure, they can actually conduct electricity in certain way. Okay, so that's solid state physics, a bit deeper than that. Okay, but for now, this is the idea. What I want to highlight in this question is that most of the time when we're doing questions involving resistance, the object that we usually study is cylindrical in shape, so the cross-sectional area is usually circle. Okay, but now I'm showing you that the cross-sectional area can actually be a rectangle as well. It can be any shape. You just need to know how to determine the cross-sectional area correctly. Okay, so that's it for this question. Thank you very much.